Good evening, this is Kevin, and tonight we're going to be talking about Newton's three laws of motion. In order to do that, we're going to have to go back to 1687, and that's when Sir Isaac Newton wrote his masterpiece, Mathematica Principia. In this work, he laid out the foundations of modern physics. It's here that he laid out the work for gravity, for force, for time, and movement. So, if you've ever been curious about why things move, this lesson is for you. So let us begin with the first law. Newton's first law says that an object at rest will remain at rest unless acted upon by an external unbalanced force. Likewise, an object in motion will remain in motion unless acted upon by another force. Now this expands on the work of Galileo in that he believed that all objects that are at rest or in motion have a certain amount of inertia, and that inertia never changes. So Newton's first law is often called the law of inertia. This simply means that objects tend to keep on doing what they're doing. It is a natural tendency of every object to resist change to their state of motion. If they are at rest, they would prefer to stay at rest. And if they are moving at a constant velocity, they would want to continue moving in that constant velocity. If we switch gears to the second law, Newton's second law talks about how fast an object would move. It says that the acceleration of an object depends on the mass of the object and the amount of force applied. In mathematical terms, Newton's second law states that the force is the product of the mass and acceleration. To cause an object to accelerate or speed up, a force must be applied. The more force you apply, the quicker you accelerate. An easy way to think about this would be if you pictured pushing a friend who's standing on a skateboard. It doesn't take much force at all to make your friend move a short distance. However, if that very same friend would be sitting inside his car and you try to push, you would have to use a massive amount of force just to move the car a short distance, and you probably wouldn't be able to push your friend at all. Newton's third law states that for every action, there is an equal and opposite reaction. So, according to Newton's third law, if an object exerts a force on another object, then that other object is going to exert an opposite and equal force on the first object. We call this an action-reaction pair. The action-reaction pairs will always be equal in magnitude and opposite in their direction. Now, these are sometimes hard to identify, so you can imagine what happens if you drop a tennis ball. As the tennis ball hits the floor, it causes a downward force on the floor. This is the action. The floor reacts by pushing on the ball with the same amount of force, but in the opposite direction. This is our action and reaction. Together, the floor and the ball form our action-reaction pair. So there you have it, Newton's three laws of motion in a nutshell. It was Galileo and Newton who came up with the theory of gravitation, which laid the foundation for Einstein's theory of relativity. There could be no clearer example of how accurate they were in predicting the laws of motion than an experiment carried out in a giant vacuum at NASA's Space Power Facility. I'll leave you with this clip from the BBC, which can be found on YouTube.